In this lesson, we're going to be solving exponential equations by using the same base. So in this example, we have 27 to the x plus 2 equals 9 to the x plus 1. So we are obviously trying to solve for x, and this would be our first method where we want to rewrite both sides of the equation with the same base. So right now we have a 27 and a 9, which is obviously not the same. So we want to think, is there a way that we can rewrite 27 and 9 with the same base? Well, first, the easiest way to look at this is to take your smaller number, which is 9, and say, okay, well, can I rewrite 27 with a base of 9? Or saying 9 to what power gives us 27? Well, if we go through our exponentials or powers for 9, we would have 9 to the first is 9, 9 to the second is 81. So right there we can see with such a large jump that there is no way that I can write 9 to some power to get 27. So although we want to rewrite them with the same base, right now it's not as obvious because 9 to some power won't get us 27. So we need to make both smaller. So is there another way that we can rewrite 9 and 27 with the same base using our powers? Well, I know that 9 is equal to 3 squared. So then the question is, if I know I can rewrite 9 as 3 squared, can I rewrite 27 as 3 to some power? Well, 3 to the first is 3, 3 to the second is 9, 3 to the third would be 3 times 3 times 3, which does give us 27. So I can rewrite 27 as 3 to the third. So rewriting 9 as 3 squared and 27 as 3 to the third means that we can rewrite this exponential equation with the same base of 3. So we start off with the 27 to the x plus 2 equals 9 to the x minus 1. So in order to solve this, we need to rewrite 27 as 3 to the third and our 9 as 3 to the second power. But we can't ignore those exponents that were already there, that x plus 2 and the x minus 1. So the 27 became 3 to the third, and the 9 became 3 squared, but that's still being raised to each of those exponents. So we have 3 to the third raised to the x plus 2, and we have 3 squared raised to the x minus 1. Well, we still then can simplify this a little bit further by using our power rule for exponents. And since we have 3 to the third raised to the x plus 2, I can actually multiply these exponents. So what we can have is 3 to the 3 times x plus 2. And the same thing would happen on the right side of our equation, is that I have 3 squared raised to the x minus 1, which I can really rewrite as 3 to the 2 times x minus 1. That way I got rid of our parentheses and it illustrates as 3 to a power equals 3 to another power. Now, using our same base rule, the equation would be equivalent if our exponents are equal to each other since we have the same base. So as long as we have the same base, we can set our exponents equal to each other and solve for x. So that means I'm looking at 3 times x plus 2 equals 2 times x minus 1. And for here, we're just solving for x. So distributing, we have 3x plus 6 equals 2x minus 2. Moving our 2x over, we're going to have x plus 6 equals negative 2. Moving the 6 over, we would be left with x equals negative 8. And that would be our solution to the original exponential equation. Now you can check this in your calculator. Remember that you always want to go back to the original. So we would be substituting in x equals negative 8. So our original was 27 to the x plus 2. So we'd have negative 8 plus 2. And the question is, does that equal 9 to the negative 8 minus 1? Well, we would have 27 to the negative 6 equals 9 to the negative 9, and you would just plug that into your calculator and you should see that both sides are equivalent. And we're done. Using this method by rewriting our exponential equation with the same base would be your most straightforward method, but unfortunately does not always work. So if you proceed to the next lesson, you'll see what to do if you can't rewrite the exponential equation with the same base on both sides.